Okay, so these are area and volume questions, and I am going to give some solution hints. So make sure that you try them first, these questions, before you listen to my hints, and then try them again. Find correct to 2 decimal places the perimeter of each shape. So remember, the perimeter is defined as the part when you walk around the outside. Okay, so this is kind of easy. You've done all that before. This looks like it could be a bit of an issue. But what you need to know is we need to find that distance. So think about how you could find that distance. Once you find that distance, you take half of it, because half would be the radius of that circle. Now you know that that's half a circle with the radius of that, and you use your circumference formula for a circle, using that as the r, and then of course it's only half of a circle, so you halve it, and that will give you that length. And then you just add them all up. So we're like that one, that one, that one. We know what that length is, that one, and that one. And that'll give you the perimeter of the shape. Don't forget the 2 decimal places. Let's think about B. Well, these are the dimensions we have. We have that dimension, we've got this part here, and we've got that dimension. Now it's probably best to start here, because if we start here, we've got 400 the whole length, and that's 200, so we know what that is, and we know what that is. This is symmetrical, right? So we do know what they are. When you know what that is, that's going to be the radius of that circle. So what you can do is it's going to be a quarter of the circumference of a circle with the radius of that. Now you could do one and then another and then another and then another, because they're all the same. Or if you think about it, you're going to have 4 of these. So that's going to be the perimeter of one circle with that radius. And that will give you all of those in one hit. Then you need to add that, and that, and that, and that, and then you should have the perimeter. Now, why don't you think about number C? It's very similar to this one. We've got 4 of these quarter circles, 4 of them, with a radius of 4. Well, it looks like a fun one. Enjoy that. 2. This diagram shows how the field is marked out for the shot put at an athletics event. Calculate correct to 1 decimal place the area of the field. Well, we're assuming this is the area of the field. That's the part where they swing around and around and then they throw it. So that's the field. All right. So it's not. It looks straightforward, but there's a bit of a twist to this one, because we could find the area of that circle. Remember, that's the diameter. We could find the area of that. We could also find the area of this sector. Let me draw that in. Good. So we'd find the area of that sector. Okay. The problem is we're counting this area twice. Okay, so that blue area would be counted twice, because when you take the area of the circle, you're including it, and when you take the area of the sector, you're also including it. So we can do the circle, and we add that to the slice of pizza here, this sector, but then we have to take away this piece. Okay, so the circle's kind of straightforward, right? The radius is 1.1, so the area is pi r squared, and r is here 1.1. The sector, it has a radius of 2.5 plus this part, 1.1. So it's going to be 2.5 plus 1.1. So that whole thing there is going to be 3.6. We know the radius, so we can find the area of the whole circle. But we only want 40 degrees of it. So the factor is going to be 40 over 360. So 40 over 360 times pi times 2.5 plus 1.1, that's 3.6 squared. That'll give you the area just of that pizza piece. Okay, so we add that, we find that, then we have to subtract this. Well, this is the same angle, that's 40 degrees, because that's 40 degrees, right? It's the same angle for both this one and also the bigger one. So what you have to do is, that's 1.1, so we have to take away this sector. Now this sector will be, if you did the whole blue circle, it would be just pi times 1.1 squared. That would be the area of everything. But it's 40 degrees only. So the factor is 40 over 360 times 1.1 squared. And that'll give you the area of the sector. Once you have that, you would subtract that from this plus this bigger one. Okay, good luck with that. B, the total length of the lines used. So these will be these orange or brownish lines here. That's easy, that one, because the radius is 1.1, so it's just 2 pi times 1.1 will give us that length. Then this one here, we know that length, and that length is 2.5. So we've got two of them. This one here, okay, that's the 40 degrees over 360 times the perimeter of a circle that has a radius, as we saw before, of 1.1 plus 2.5. And then we can find that length. And then we add all those together. Question 3. Mathland has introduced a new 30-cent coin. Okay, when you visualize this, it looks like it's 3D, but it's not. It's just flat. As shown on the right in the first diagram. The angle ABC is an equilateral triangle of length 2 centimeters. So we already know if that's 2 centimeters and it's an equilateral, that's 2 centimeters and that's 2 centimeters. We also know, because it's an equilateral triangle, that that's 60 degrees, that's 60 degrees, and that's 60 degrees. Keep that in mind. And the arc AB is shown in the second diagram, centered at C. Okay, so that's centered at C. So if you think about it, that C is there, that A is here, and that B. So this sector here is actually that thing. Remember, it looks 3D. This is not 3D, it's flat. Okay, so that sector is that. So we know that length is 2 centimeters, it says it, and it shows it here. A to B is that length there. Okay. A, find correct to 3 decimal places the area of the sector in the second diagram marked I. So we have to find the area of that. Well, just like we saw in the previous question, the factor, it's not the full circle, right? It's not the full circle. So we can't use R as 2 and use pi r squared because it's not the whole circle. There's a factor of 60 divided by 360. It's only 60 over 360 of a circle. So 60 over 360 times pi times 2 squared should give us the area of that sector. Okay, same question. B, use Pythagoras' theorem to prove that the perpendicular height of, that says angle, but it's a triangle ABC is root 3 centimeters. Think of this triangle here, ABC. It's an equilateral triangle, and we've got to find the perpendicular height. The perpendicular height is from here straight up to A. Let's drop straight through there. Okay, let's draw that. Okay, so that's the same triangle, ABC. They're asking us to find that length of that green line because that's the perpendicular height of this triangle. Now, what do we know about that? That point there is directly above the midpoint between C and B because each side is 2 centimeters. So if that's the case, that's still 2 centimeters, 2 centimeters. This now is 1 centimeter and 1 centimeter. Okay, just keep in mind perpendicular height means that that's at a right angle. So the green line meets that red line at a right angle. Okay, that's why we can say, let's use Pythagoras' theorem for this. We know that's 2. We know this is 1. So 2 squared equals 1 squared plus x squared. Or this line here squared, the length of that line squared equals that length 2 squared minus 1 squared. And then if you want to find what it is, it would be that length of that line equals the square root of this squared minus this squared. Now C, calculate the area of triangle, it says angle, but the triangle ABC correct to 3 decimal places. Well, we just use the formula for the area of a triangle, which is half the base times the height. So we should be able to do that to 3 decimal places. Now question D, it's the same question, but part D, calculate the area of the shaded segment in the first diagram. Okay, in the previous parts, we got the area of that triangle and also the area of this sector. So if you have to find the shaded part, it's going to be the area of the sector, what we found for that, minus the area of the triangle, what we found for that. So that's D. And then E is where it all comes together. Hence, and when you see the word hence, it means use the information from previous parts. Calculate the area of the 30-cent coin. Well, we just saw in D, we got that area. We got 3 of them, so it's 3 times what we found in D, plus the area of the triangle, should give us the area of the coin.